So today we're going to look at the GFL-1000 ground fault locator. This is a great tool for locating DC ground faults on DC bus and batteries. So essentially the system is comprised of two main components. There is a signal generator, which is what is going to be connected to the bus and is going to inject a small AC signal. And the signal receiver is what you're going to use to trace that signal and eventually trace it to the location of the ground fault. So this video is going to be a quick tutorial on how to do the initial setup and how to trace on the battery. So one of the first things you're going to have to do is identify which side of the system, the positive or negative side, the fault is on. This is going to determine how you connect up to the battery and to the bus. So you're going to need a multimeter or voltmeter, or otherwise some other sort of monitoring that can tell you the balance, the voltage balance on the system. So in this case, I have created a simulated fault on a battery system here. So you can see I connected a unintended path to ground and just have a little ground terminal there. So I'm going to check my bus voltages, and the lower voltage side is going to be the side which has the ground fault. So if I check from my negative bus to ground, I'm seeing 17 volts, and this is a 48 volt system. So it is on the negative side. I can check the positive side as well, and it should be a higher voltage. But I already know that this is on the negative side, and so once I've identified that, now you can go and actually go to the generator, and you'll be able to connect up to the system accordingly. So this is the signal generator, and you're going to have a black and red lead for the signal output. So you're going to want to grab your leads when you're ready to connect to the system. So once you have your leads ready to connect to the system and you've identified which side the fault is on, you're going to connect one lead to that side of the bus and one lead to the ground. So in this case, we had a fault on the negative side of the string. That means I'm going to connect my black lead, my negative lead, to the negative bus. My red lead is going to then go to the ground. If it was the opposite and it was on the positive side, you would connect the red lead to the positive bus and the black lead would go to ground. So here's our negative bus, start of the string. And we're going to go to the same ground terminal over here. So that's all connected now. And essentially now you can start to set up your output signal from here on the signal generator. So one thing you'll also have to keep in mind, and it's really one of the most important aspects of using this unit, is it does inject a small AC signal onto the battery. And if you have other AC sources also in the same circuit, it's going to cause potential interference and false readings. So you want to, in order to get the best tracing results, ideally you want to eliminate any of those AC sources. What that means in practical means is essentially you are going to need to disconnect or isolate the charger. So most systems are going to have a battery charger with a built-in bridge ground fault detection circuit, and you're going to need to isolate from that because that's going to be a type of signal that causes interference. So that is a very important step, making sure to isolate completely from the charger or disable that so that there is no other AC interference that's going to affect your tracing. But once you've done that, now you can get ready to set up on the signal generator. And it's going to just be a couple of steps going through the settings on here. Mostly you just need to set the output voltage and if you want to have limited current or not. So if we go to the ground fault selection, you will see there's going to be a voltage selection and a current limiter selection. In this case we have a 48 volt string, so that's what we're going to select. The closest voltage that you have to your actual string is what you're going to want to select. And the current limiting, it'll either be unlimited or you can limit it to a 5 milliamp current if you need to have less current on the string due to sensitive electronics. Typically you can stick with the unlimited setting and we'll proceed with the next button. So it's going to do a little calculation the first time you select this. and it's going to give you its initial readings. You can see it'll give you the capacitance, the current output, and the resistance that's being measured. And you're going to press enter to proceed past this. This next screen, it's going to have adjusted if it found any differences, if it sensed a different voltage or anything like that and needed to adjust automatically. It's essentially confirming your initial settings. So we're going to go through this page one more time and enter. And now we're on the actual output page. You can see once it loads in that now you'll get a live reading of the voltage to ground, the current output, and the resistance again. And it is outputting a continuous signal. So the signal generator is now set up and outputting its signal. So the next step is to go to the signal receiver. This is your handheld receiver. You're going to have the dual current clamps. You can use one or both for the tracing process. And you'll notice these have a arrow on them, which points in the direction of the current. The signal receiver, we're going to first essentially have to tell the signal receiver what type of signal it's looking for, which is called setting the reference. So the first step is going to be actually using one clamp of the signal receiver. You're going to clamp it around directly at the output of the generator, going into the bus or the battery. And you're going to have the arrow facing away out of the generator. Now which lead you clamp it around is dependent on which side of the bus you're on. In this case, because it's a negative fault and we're connected on the negative side, we're going to go around the black lead. So we take our current clamp and clamp it around the black lead, and the arrow is facing out of the generator into the system. You only have to use one clamp for this step. Now we're going to look at the signal receiver and we're going to set the reference signal. So you'll go to your ground fault option. It's going to be defaulted to a 10 hertz frequency, and then there's optionally you can have audible beeps for when you're tracing. We'll leave that off for this case. So you press OK and you're going to see this screen here. One more time you're going to press enter and it's going to set the reference at this point. You'll get a little message there that it says setting reference, and it'll take a few seconds. And what it's going to do is it's going to set your signal as if it were 100% strength, 0 phase angle, and a green directional arrow. So you can see at the top of the screen here, that is the parameters you're going to be viewing while you trace. And ideally, when you start, it should be 100% strength signal, 0 phase, meaning it's a resistive fault, and green arrow indicating which direction your clamp is facing. So at this point, we've now just set the reference. Whichever clamp you used to set the reference is going to become your main clamp, your primary, and you also have your secondary. It's kind of optional. If you want to, you can just use the main one. You can also use them both in conjunction. So at this point is when you can actually go and begin the tracing on the system. And you're going to start from where you're injecting the signal and follow that signal, whether it's in the battery where the ground fault is or past the battery in the distribution. You should be able to now follow from point to point and get to where the actual ground fault is located. So you can see, we'll just give you an example of how you would start the tracing. You're going to start looking into the battery, and so if I clamp my current clamp around, right now it's looking into the battery system. As you can see, the fault that I have simulated farther into the battery is in front of the clamp, and if you look at the readings, we can see that it's seeing it full strength, 100% strength, and 0 phase. So that means it is indeed this direction, and you would continue to follow this direction. So throughout the tracing process, you're going to follow that strength. It's going to slightly dip if you get farther and farther distance into the system, and if you ever needed to, you can actually reset the reference at a farther point in the system if the signal strength is falling off too much. But otherwise, you're also going to look at the phase angle. The phase angle is going to tell you if you're looking at the resistive fault or if there's any capacitive or inductive elements. So if there were any capacitive or inductive elements, you would see that in the phase angle going high or low. And typically this means what you're maybe looking at or facing towards might not be the ground fault. It could be some other elements, some other filters or whatever in some panels. There's all sorts of different things in these DC systems, so you do have to use your best judgment to identify what you're looking at, but ideally you're going to follow from point to point, follow where it's zero phase, and you have that directional arrow. Now you'll notice if I were tracing and I continued on, and let's say I got to this point here, which you'll notice is past my point of the ground fault. So for example, this is what it looks like once you've, when you don't have the signal. You can see the I direction turns into a red cross over the arrow. That means it's not in this direction. And my signal strength is extremely low. You usually want to let your readings stabilize once you put the clamp around for a couple of seconds, but in this case you can clearly see it lost the signal. It's not facing this direction, so in that case I know that I'm past it and I need to go the other direction. So you can use this if it's, for example, past the battery, it's in the distribution, you may need to check multiple paths, check multiple branches. So you can identify and look through and check from point to point and figure out which one is actually has your fault. You can also use both clamps to go around two conduits at the same time. So there's a couple of different ways you can use the clamps. But otherwise, at this point, again, you would continue to trace. Now in this case, I made a pretty simple example here. Every system is different, so you really just need to do your best to follow, use your best judgment, and if you have a basic understanding and you set it up correctly, you should be able to find that location of your ground fault.